All right, good morning and good day. Welcome to another edition of Mr. D's math class. So welcome my students and students of the world. This is our exercise on dividing fractions. In the textbook that we're using, my students, this is titled 3.6, dividing fractions. So in this video, we're going to show you how to divide fractions and also how to model it on a number line. Okay, so might as well start with the first example. And you know what, I might as well use some examples that are actually from the exercise itself. So in this example, 9/10 divided by 2/5. Now remember, for my class, the best way to look at this division is to ask how many 2/5 are there in 9/10. So I'm just going to write that down so that we know what question we are answering. How many 2/5 are in 9/10? All right, well, let's find out. So in the exercise booklet that we have a fraction, we have a number line that goes from 0 to 1, and you know they did divide it into tenths, but in between those tenths they also put in the fifths, so they used both denominators 10 and fifths in that number line. So it's gonna look something like this: 1, 2, 3, 4. Okay, so now these are actually in tenths. So this is 1/10, this is 2/10, but it is also equal to 1/5. Okay, therefore there's 3/10, 4/10, which is also equal to 2/5. Okay, and that's the way a number line looks like. Instead of having 4/10 here and 2/10 here, they have 1/5 and 2/5. This 1/2 obviously is going to be 5/10. The next one will be 6/10, which is equal to 3/5, and then 7/10. Notice all the even numbers can actually reduce to fifths. Okay, and finally 9/10. Here we go. So what is this question asking? How much of 2/5 are in 9/10? Well, first of all, I want to find out where 9/10 is, and 9/10 is from here all the way up to here, if you can see it. Okay, there's my 9/10. Now I'm going to find where my 2/5 is. It's right here. So this is my 2/5. So the question is, how much of this is in here in the 9/10? Well, so far we've counted 1. So from here we actually know that every 1, 2, 3, 4 notches is a 2/5. So we have 1, so we're going to count another 4. 1, 2, 3, 4. So now we have actually 2 2/5 in there so far. But now, what is this little piece right here? We still have this one little piece. So listen to what I'm saying. What this is actually how much of that, like this part is a quarter of this 2/5, because each 2/5 is worth like 4 pieces, 4 notches, and this is only like 1 of those 4. So in other words, how many 2/5 do we have? We have 1, we have 2, and a quarter of 2/5, because this is only a quarter of this 4. Okay, so this last piece is only a quarter. So now to answer our question again, how many 2/5 are there in 9/10? Well, we have 1, 2, and a quarter of 2/5 in 9/10. That's how you use it to model a number line. Now, if we just do the math to check to see if we're correct, here comes the math, or the algorithm on how to divide fractions. Okay, when you're dividing fractions, really all you're doing is multiplying by the reciprocal. So maybe I should actually do this vertically. So what I'm going to do is 9/10. So this first fraction always stays the same. This first guy stays the same. This gets converted into a multiplication, and this, you just flip it over. Okay? And the statement for this really is multiply by the reciprocal. And I think we've talked about reciprocals and inverses in the previous videos, so hopefully we don't have to review that. We've also reviewed greatest common factors in fractions, and you can reduce those before you do your multiplication. So do you notice that 5 is common to both 5 and 10 in this numerator and this denominator 10? So you can reduce those first if you like. Divide both of those by 5. 5 divided by 5 here is 1. 10 divided by 5 here is 2. And now here's your simpler multiplication. Between the 9 and 2 there is no common factor, so this is your new multiplication. Okay? And so when you multiply this, we get 9 times 1, which is 9, and 2 times 2 is 4. Okay, so students, remember, we still need to reduce this because this is a top heavy. When you have a top heavy or a bigger number in the top, you have no choice but to convert this into a long division. And so now we're going to divide this. How many 4s are in 9? I think there's 2. And then 2 times 4 here is 8. And so this 9 minus 8 is our remainder 1. So our answer here is 2 1/4. And isn't that the answer that we got here above? So how many 2/5 are there? Again, let's review this number line. How many 2/5 are there in 9/10? Well, here's my 9/10. Here's my 2/5. How many of this are in here? I have 1 and I have 2. And I can only fit another quarter of this 2/5 in this little piece. That's what 2 1/4 of 2/5 means. Okay? Maybe we'll try one more example just to hit this home. So for example, let's try this one. 2/3 divided by 4/9. Okay, let's straighten this out a little bit. Let's see this on a number line. Okay, so from here, I guess what's the best denominator to use? I think the best denominator to use is the greatest one, or sometimes the LCD would be best for this. In this case, the lowest common denominator between 9 and 3 would be 9. So what I think I'm going to do is I'm going to divide these into 9s. But really the easiest way to do this is really start with thirds. So 1/3, 2/3. So now how do I divide these from 0 to 1 into 9 pieces? Well, I'm just going to divide each of these into thirds also. And so now I do have 1, 2, 3, 4, 5, 6, 7, 8, 9. Where this is 9 over 9 equal 1. So I'm going to start with this as 1/3. This is 2/3. What about everybody else? Well, I'm going to use this as 1 over 9, 2 over 9. Okay. 3 over 9. This is what 3 over 9 would look like. 4 over 9. 5 over 9. This is what 6 over 9 would look like. It's equal to 2/3. And this one, 7 over 9, 8 over 9. Okay? So now, my question is, how many 4/9 are there in 2/3? Well, the first thing I got to do is find out where my 2/3 is. And it's from here to here. From here to here, this is my 2/3. Okay? And where's my 4/9? Well, it's right here. There's my 4/9. So the question is, how many of this 4/9 are in 2/3? How many of this, or how much of this is in here? This 2/3. Well, I've already counted one. There's one. How many more do we have left? We have this piece still. Well, how much of this is actually this 4/9? It looks like, well, 4/9 is 1, 2, 3, 4 notches. And this little piece here is only 2 notches. So that's only 2 out of the 4. So this 2 out of the 4 is only a half. So my guess, how many 4/9 are there in 2/3? I think our guess is 1.5. Because there's only 1.5 of 4/9 in this 2/3. Okay, I hope that makes sense. And that's how you model dividing fractions on a number line. So now let's check our answer to see if it's correct by doing the algorithm and the math. We should get 1.5 as our answer. Multiplied by the reciprocal, 9/4. I could see that I can actually reduce these fractions, the diagonal numerator and denominators, 2 and 4. And I can also reduce this 3 and 9. 2 goes into both 2 and 4, so 2 divided by 2 is 1, 4 divided by 2 is 2. 3 goes into both 3 and 9, so 3 divided by 3 is 1, 9 divided by 3 is 3. And now, my simplified multiplication is 1 times 3, and then 1 times 2. Okay, so then 1 times 3, 1 times 2 is 2. And unfortunately, we still have a top-heavy number. So now this has to be converted into the division, where how many 2's are in 3? That is 1. 1 times 2 is 2. And then we subtract this to get our remainder. So look at our answer. It is 1.5, which is the exact same answer that we got up here. 1.5. Okay, so there's the algorithm in math. Make sure you just multiply by the reciprocal. Okay, you flip this over, and then this turns into multiplication. That's how you do dividing fractions. And here's the model. In other words, how much of this is actually in that first fraction. The first fraction is 2/3, and how much 4/9 are there in this whole thing. It looks like we counted 1. And this is only half of this, so 1.5. Okay, so I hope you view this video to help you. Hope you show it to your parents. If your parents see it and they want to help you, you could at least, view it over and over. You could pause it, you can reverse it to see where you left off, if you miss anything. And I did do 2 examples here, so I wish my students luck, and I hope they do view this, and I wish all the kids in the world who need to do this, wish you luck as well, and I hope it does help. Thank you for viewing. Bye bye for now.